our team?
Maths is fun.
Maths is fun. Go Neon. So we're making our mind stronger. And the stronger your mind, the easier, the simpler mathematics becomes. And what are you going to say?
I love mathematics.
Come on, say it with some energy.
I love mathematics.
Good. Now, we're continuing in this lesson with measurement. We're looking at area. And we're looking at area of quadrilateral. I'm going to underline the first 4 letters, quad. And we call quad a prefix. Good? Now what does quad, when you hear the word quad, what number comes to your mind?
4.
4. So if we're looking at area of polygons, these polygons have got to have how many sides?
4 sides.
4 sides.
Approximately.
No, Quincy. Not approximately. They have got to have 4 sides. So, some of the basic ones we're looking at would be the square. Yes, Quincy?
Rectangle.
Rectangle.
Trapezium.
Yes, Kieran?
Trapezium.
Trapezium. Parallelogram. And the parallelogram. Remember again, when we talk about the area, we're looking for the size of the surface that is enclosed by those 4 straight sides. Good? Now let us start off with the square. And it's always really nice to know the properties of a square. Alia, what can you tell me about the sides of a square?
All the sides are equal.
All the sides are equal. They have the same length. And if the sides are equal, Miracle, what can you tell me about the internal angles?
All the angles are equal.
All the angles are equal. And what is the size of each angle?
90 degrees.
90 degrees. So if this is a square, and we call here L, and we call here L, the formula that we would use to find the area of a square would be
L squared.
L squared, which would be L by L, and that would give us L squared. Now, a square is a plane figure in which all sides have the same length. A square is always a rectangle. Always. Because a rectangle is a quadrilateral with 4 sides. And the opposite sides are parallel and equal. They're all equal. Now let's go back to the square. And the opposite sides equal?
Yes.
Yes, but only thing, this is a special rectangle. All 4 sides have the same length. Now if we go the other way, all rectangles are not squares. Because we can have a situation like that. But all squares are rectangles. Okay? Now let us say I come here and I put here 10 cm. And I ask you, without computing, tell me the area of this square. What would it be?
100.
Oh, Quincy, you're there today. The area of this square would be 100 cm square. How did Quincy come up with that, Neon?
Because 10 squared, or 10 times 10, equal to 100 cm
Yeah,
squared.
just add a 0.
Now, Quincy said that if one length is 10 and he multiplied by another 10, same length, he would have 10 tens, giving us 100. Very good, Quincy. Good. So the area of a square is very simple to find. Now let us move from the square to the Rectangle. So here we have a rectangle, A, B, C, D. And when you were in Form 1, Kieran, what was the formula you used to find the area of a rectangle?
Length times
Area A is equal to length times
width.
width or breadth. Good. It can be LB or LW. Good. Here we have 9 meters and here we have 4 meters. We want to substitute the 9 and 4 into A equals LB to find the area or the surface, the size of the surface of this particular rectangle. What would be the L? Vanelli?
9 meters.
9 meters. Therefore, the breadth would be 4
4
meters.
meters.
And 4 nines are
36.
36 meters
Square.
square. Now, in a previous lesson, we looked at this question here. And this question here is a CXC question. Now, I don't want you to feel that you hear the word CXC and you get all afraid. Oh, I can't do it. No. Now, let's conquer it. We looked at A and B where we found the length and we found perimeter. Now, I added a third part. C. Calculate the area of the entire floor. Now, when you look at this floor, it's a combination of A and B. And what shape does each floor take?
Rectangle.
The shape of a rectangle. And how many rectangles do we have there?
2.
So if we want to find the shape of the entire floor, what should we do? I'll take Quincy with that.
Find the area of each rectangle separately and then add them.
So we find the area of rectangle A, find the area of rectangle B, and then we're going to find the sum of those two products. So I'll have the first 3 finding the area of rectangle A, and the second 3 finding the area of rectangle B. Yes, Videli, what you got for the area of A?
50 meters.
50 meters square. Did you get that, Quincy?
Yes.
Kieran, you got that?
Yes, miss.
How did Videli get 50 meters square?
So she multiplied 10 by 5.
She multiplied 10 by 5. So the first thing you're supposed to state is your formula. The length by the breadth. We substitute second. The length would be
10 meters.
10 meters by 5 meters. And the product of 10 and 5 would be 50 meters squared. So we bring down our 50. Area of floor would be the area of A plus B. So here we have 50. Second. Yes, Miracle, what was your answer?
24 meters.
Did you get the same thing, Nian?
Yes.
Alia?
Yes, miss.
Good. Now, Alia, we're going to state first of all our formula, which is length by breadth. What is the length, Alia?
8 meters.
8 meters. And then we multiply it by the breadth, which is 3 meters. And 3/8 are
24.
24 meters
Squared.
squared. So we're going to add 24 meters squared here. And our sum would give us
74
74 meters squared. So isn't that really, really simple?
Yes.
Yeah. That's really simple. So now because it's grade 9, you can conquer CXC with this knowledge. Okay? Good. So, first of all, when we started with the quadrilaterals, we looked at the area of a square. And then we moved from square to rectangles. So we have completed 1 and 1, 2. Now let us move thirdly to parallelogram. Have a representation of a parallelogram. And here we have one here. Now, before we get to that, now let us look at the parallelogram. And let us look at some properties in relation to the sides. Who would like to volunteer? Go, Neon.
In a parallelogram, the opposite sides never meet.
The opposite sides never meet. And if they never meet, that means that they are parallel. Apart from them being parallel, the opposite sides are equal in length. Now, we did a shape before, and the shape is called rectangle. Now, let us see what happens if I cut off this piece here on the parallelogram. So I'm going to cut along here, which is the height of the parallelogram. And I'm going to take this piece and I'm going to attach it across here. And what shape have I taken the parallelogram and make? A rectangle. And I did this because we're going to use the formula that we use to find the area of a rectangle to find the area of a parallelogram. Because here we have the base and here we have the height. Okay? So here we're going to have area A is equal to base by height, or we can use base by, or the length by the width, or the length by the breadth. Good? Now let us find some figures now. Here, I'm going to insert a perpendicular here to tell you that this is the height, and the height here is 11 centimeters. The base of this parallelogram happens to be 15 centimeters. I would like you to find the area of this parallelogram. 165 centimeters square. Now we're going to prove that in a minute. But when you see this H here, this H is not just any H. This H is the perpendicular height of the parallelogram, which is equivalent to the width or the breadth of the rectangle. Okay? Now you have to see this perpendicular here. Good. Now let's substitute. The base, what did you use as a base?
50
centimeters by the height, which is 11 centimeters. And you got 160 centimeters square. Any difficulty?
No.
Is math difficult?
No.
No, can't be. Need another one there? Want us to try another one?
Okay.
So you always state your formula first. Area of paragram A is equal to base by height. What was the base?
32 millimeters.
32 meters.
Millimeters.
Thank you, Quincy. Multiply by
17
17 millimeters. And what was your answer?
544 millimeters squared.
Let me see how those will get distinction when they write the exam. Oh, lovely.
Lovely.
Way to go. So we looked at the square, the rectangle, and the parallelogram. Now let's go conquer the trapezium. On the trapezium, two sides are parallel to each other. The other two sides will meet at some point. These two sides here. Only these two sides here wouldn't meet. Good? Now we are interested in finding the area of that shape. Now let us go back a little. What's the first shape we found the area of?
Square.
Triangle. Good. Now we're going to use our knowledge of triangles. So what we're going to do, we're going to take this trapezium and we're going to make triangles out of it. So we have triangle number 1, triangle number 2. And we know that the height of this trapezium is here. We're going to call here H. And let us call it E, F, G, and H. Whether it's E, F, and H, that's the height, or if it's F, G, and H, this is still the height. And we know that in a triangle, the area A is what? Half base by the height. Now let us look at the first triangle. Let us look at EFH, this one. Area A is equal to half. The base would be EF by the height, which is H. Now let's look at the second triangle. The base in this case would be HG, half HG, multiplied by the height, which is H. Now when we look at what we have for the two areas, we notice some commonalities. They both have half, and it's half of the two sides that are parallel, and then H is common again. So let us take these two and fit them together so we have one. So we have a half is common, and a half of what? EF, and it's a half of HG. And they are both being multiplied by the height. Now how do we connect the middle? Triangle FGH and the sum of triangle EFH would give us the area of trapezium EFGH, the sum of these two. So we're going to add at the middle there. So to find the area of a trapezium, we add the pair of parallel sides, find half of that sum, and we multiply by the height. So you'd hear people say, half the sum of the parallel sides by the height. Capiche?
Capiche.
Good. Now let's put our knowledge to work. Let us look at this question across here. This was CXC 1995, question 5A, and we're interested in part 2. Part 1, they want the length of dx. Now when we get down to find the Pythagoras' theorem, we're going to find the length of dx there. But the length of dx is actually 12 centimeters. Good? Now let us go. In the trapezium, DEFG above, not drawn to scale, DE is equal to 10 cm. DG is equal to 13 cm. And GX is equal to 5 cm. Angle EFX and angle DXF are right angles. Calculate. We're interested in part 2, the area of the trapezium DEFG. Now let's fill in what we're given here. We're given DG, which is 13 cm. We're given GX, which is 5 cm. And we're given DE, which is 10 cm. We're asked to find the area of that trapezium. Now we're going to do two things. Before this, we looked at area of triangles and area of rectangles. We're going to take this shape and we're going to make two shapes out of it. A triangle and a rectangle. The rectangle, what would be the length of the rectangle?
10 cm.
10 cm. What's the width of the rectangle?
12 cm.
12 cm.
Somewhere
What is the base of this triangle here? The length of the base?
5
5 cm.
5 cm. And what is the height?
12 cm.
12 cm, the same height across here. So to find the area of that trapezium, we're going to find the area of the rectangle, find the area of the triangle, and we're going to sum them up. And when we finish, we're going to try a second method, which is half the sum of the parallels
How long are these?
This is the last piece here you're wrapping up. This is the last piece. When you're ready. When you're ready. I'm ready. Good. So let us go ahead and find the area of this triangle here. Area A is half base by height, which is half of 5 by 12, and that would give us 30 cm square. Then we're going to add that to the area of the rectangle, which is length by breadth, and that would give us length, which is 10 by 12 cm, and 12 tens are 120 cm square. So the area of that trapezium would be 30 cm square plus 120 cm square, and that would be 150 cm square. Now let us try this formula here. So it's half. Now let us call the two parallel sides A and B, and we multiply by H. A, let us call A 10. So it's half of 10 plus, what is the length of GF? 15 cm by H, which is 12 cm. So it's half of 25 cm by 12 cm. And what is our answer?
150 cm squared.
150 cm square. So you see how the area of rectangles and the area, knowing the area of rectangles and triangles have helped us to find the area of a trapezium. Okay? If you're not comfortable using this formula, then you can go ahead and put two shapes together. Or you could have used the case where we had previously. You take the trapezium and you make two triangles, and then you sum the products. Good? Now, in this lesson, we looked at area of quadrilaterals. And the quadrilaterals we focus on were the square, the rectangle, the parallelogram, and the trapezium. Lesson 16, measurement area of polygon 1. In this lesson, we will solve problems involving area of triangles. What are polygons? A polygon is a closed plane figure bounded by at least 3 straight lines. The polygon takes different shapes depending upon the number of its sides. A regular polygon has sides of equal length and angles of equal measure. Here are some regular polygons: regular triangle, regular quadrilateral, regular pentagon, regular hexagon, regular heptagon, regular octagon, regular nonagon, regular decagon. Types of triangles: equilateral triangle, isosceles triangle, scalene triangle, acute angle triangle, right angle triangles, obtuse angled triangle. Here are some key points. Area is the entire surface covered by any plane geometric shape. The area of a plane figure is the amount of square units it contains. Area is measured in squared units. cm multiplied by cm equals cm squared. What can we say about the area of a rectangle and a right-angled triangle? Let us find the area of a right-angled triangle. Area of rectangle ABCD equals 18 cm square. A, B, C, D. Area of triangle ABC, ABC triangle, is equal to 18 divided by 2 cm square, is equal to 9 cm square. Therefore, area of right angle triangle is equal to half base times height. Example 1. Find the area of a triangle whose base is 20 cm and height, base there is 20 cm and height 44 cm, the height there 44 cm. Solution: area of triangle equals half base by height. Half by 20, the base, by 44, the height. cm squared is our unit, equals 440 cm squared. We can also find the area of triangles that are not right angled. We know that A equals half base by height. But what happens when H is not given? Area of triangle ABC equals the square root of S into S take A by the S take B into S take C. Where S is the semi-perimeter, and that is equal to A plus B plus C divided by 2. Example 2. Find the area of triangle ABC whose sides are of length 5 cm, 6 cm, and 5 cm. 5 cm, 5 cm. In the triangle ABC, let A equal 6 cm, B equals 5 cm, and C equals 5 cm. The semi-perimeter S equals 6 plus 5 plus 5 divided by 2 cm. Semi-perimeter S equals 6 plus 5 plus 5 divided by 2 cm equals 16 divided by 2 cm equals 8 cm. Area of triangle ABC is equal to the square root of S into S take A into S take B into S take C, and that is equal to the square root of 8 into 8 take 6 into 8 take 5 into 8 take 5, and that is equal to 8 by 2 by 3 by 3, and that is equal to the square root of 144, equal to 12 cm square. Summary. Area of a right angled triangle is equal to half by the base by the height. Area of triangle is also equal to the square root of S into S take A into S take B into S take C, where S, the semi-perimeter, is equal to A plus B plus C divided by 2. Problem for today is taken from Mathematics for Secondary Schools in Guyana, Book 3. It will be found on page 51, exercise 4C, questions 12 and 14. Solution for the problem given in the last lesson. Page 44, exercise 4A. Question 2. A kitchen garden is made up of a rectangle and a square as shown in the diagram. What is the perimeter of the garden in A, meters, B, centimeters? A, perimeter P is equal to 20 plus 10 plus 5 plus 5 plus 15 plus 5 meters. And that is equal to 60 meters. B, perimeter P is equal to 2000 plus 1000 plus 500 plus 500 plus 1500 plus 500 centimeters, and that's equal to 6000 cm. 6. What is the perimeter of a polygon with sides ACM, A plus 1 cm, A plus 2 cm, and 3 into A plus 3 cm. P perimeter is equal to the sum of A plus 1 plus A plus 2 plus 3 multiplied by A plus 3 cm. And that is equal to A plus 1 plus A plus 2 plus 3A plus 9 centimeters. And that is equal to 6A plus 12 cm, which is also equal to 6 into A plus 2 centimeters. Page 46, exercise 4B. Question 2. Calculate the circumference of a roll of paper tape with diameter 11 cm. Take pi equals 3.14. Circumference C equals pi d. C is equal to 3.14 by 11, and that is equal to 34.54 cm. Questions 10. The radius of a bicycle wheel is 28 cm. How many complete revolutions will the wheel make in traveling 1 kilometer? Take pi equals 22 over 7. Circumference C is equal to 2 pi r, and that is equal to 2 multiplied by 22 over 7 equals, multiplied by 28 equals 176 cm. 1 km equals 100,000 cm. 176 cm equals 1 revolution. 100,000 cm is equal to 100,000 divided by 176, and that is equal to 568 revolutions. If you know the area of a rectangle, you can easily calculate the area of a parallelogram. The area of a square is simply the length by the length. You can take a trapezium, make it into 2 rectangles, make it into 2 triangles, or make it into a triangle and a rectangle. You find the products and then you sum them. Is maths difficult? No. Remember, you can conquer the world with knowledge in mathematics.